everyone, I'm Wendy. I explained categorical data and its distribution, multinomial distribution, when we have three or more categories. Okay, first, goodness of fit test, how it's going. Okay, let's see. Goodness of fit is briefly GOF, first letters. Let's consider damaged die. The die is damaged. We want to test whether the probabilities of each face appearing are the same or not. In this case, the hypotheses are H0. The die is normal. Okay? H1, die is not normal, is abnormal. Die is normal, that means P1, P2, P6 are equal to 1 over 6. And H1, if die is abnormal, then at least 1 over Pi is not 1 over 6. To conduct hypothesis testing, let's assume we roll the die 100 times as a sample. Then the number of times phase 1 appear will be x1. Phase 2 will be x2, and so on up to phase 6, x6. These are referred to as being not yet observed frequencies. Okay, so random variables x1, x2, x6 are random variables, not observed yet. So it is a theory, easy, simple theory. Since hypothesis testing is conducted under the assumption that H0 is true, it is fair normal die. That is assumption. If H0 is true, the expected frequencies for phases 1, 2, and 6 are expectation value of xi, say ei, okay, is 100 times 1 over 6, right? If H0 null hypothesis is true, this one true, then I from 1 to 6, right? In this context, how should we determine the test statistic? Think about that for a while. If the difference between observed frequencies and the expected frequencies is large, is big magnitude, shouldn't we reject the null hypothesis H0? Okay, it means xi minus ei is big, positive or negative anyway, big, then some of them, we may reject H0. Okay? So here, category 1 to 6, observe the frequencies x1, x2, x6, and expected frequency E1, E2, E6. Okay? Let's assume the categorized data is as follows in general. That is, for the categorized data classified into K categories. So X1, X2, Xk. If the probability for each category is Pi, then hypotheses are this is simple example. The hypotheses are H0 will be P1 equal to P10. Subscript 0 means given value, some value. P2 equal to P20. Pk equal to Pk0. What is this sum of this? Sum of P I0, I from 1 to k should be equal to 1, right? Okay, H1 at least 1 over Pi is not equal to Pi0. That we will denote it tilde H0 shortly. This hypothesis testing problem is called goodness-of-fit test. This kind of a thing is a goodness-of-fit, okay, the hypothesis. And the test statistic and its distribution are this way. Observed frequency minus expected frequency difference squared divided by expected frequency EI and sum of from 1 to k, all these terms sum up. That is chi-square, and this chi-square tested statistic follows chi-square distribution with degrees of freedom k minus 1. Why? Sum of xi equal to what? I from 1 to k equal to n. So they are k minus 1 independent xi's. Understand that? Because sum of these x's equal to n. So x1, x what k minus 1 are independent. Then the last one, k xk, should be n minus x1 minus xk minus 1. That's why they are k minus 1 independent random variables. It's degrees of freedom. And it is important to note that when dealing with categorized data, the sample size must be sufficiently large. If you have a sample size just about 25, 30, that is not good enough. It's of course depending on the number of categories. Additionally, if the number of categories having an expected frequency less than 5, EI less than 5, number of categories having this condition exceeds 20% of the total number of categories, then the result of a chi-square test, this test, will not be valid. In such cases, you may combine the categories with expected frequencies less than 5 with neighboring categories, so that the number of categories with expected frequencies less than 5 does not exceed 50 of the total. You understand that? If number of categories with this, okay, then you have to merge neighbor or related categories. So the result, if the result is number of categories with expected frequency less than 5, does not exceed 20% of the total. Total means k. We have k categories, then that's okay. This adjustment is called Cramer rule. This is very well used for categorized data analysis. I will show simple example later, okay, in order to apply Cramer's rule. Okay, isn't it simple? That's it today. Thank you. Bye.